We're looking at complex numbers today. Complex numbers, and as you know, there are many parts of complex numbers. But I want to look at finding real and imaginary part of a complex number, from a given expression. After which we look at how we can be able to do the derivative of a complex function. Yeah. So moving forward, without wasting our time, you can see on the board on the board or screen, you can see this write up everything that is written there. So the complex number is written as z equals to x plus iy, which is very true. And as we know, I square is equals to minus 1. Very, very important part you need to know in complex number. Whereas I is root of minus 1. So I square is equals to minus 1. So S, as we know, is the real part, Y is the imaginary part. Just like you have this function now, the 3 is the real part, then the 4 is the imaginary part. So RE means real part of Z. That's what this means. So and equals to 3, and imaginary part of Z, that's equals to what? 4. So that's the next thing now, finding the real and imaginary parts of a complex number. Said it is written in complicated form. We must simplify. You see, if it is written in complicated form, we must make sure we simplify it to be able to decompose it to the point where we can get the real part separated from the imaginary part. Then we can now identify from there. Now we have an example here. Example A. It says, it said, given that z is equals to 2 plus I over 3 minus I, we're going to find the complex part, the imaginary part and the real part of that function now. Now, this is one fraction. This is the question, just one fraction. We cannot tell the real part and the imaginary part. So what we have to do is that we have to find a way to break it into 2 or more, depending. But we have to break it into 2 because at this point we look at 2 things. So we're multiplying both the top and the down, that's the numerator and the denominator, by the conjugate of 3 minus I. The conjugate of 3 minus I is 3 plus I. 3 plus I. I would always tell students that the conjugate is not just changing sign. It is changing the sign that is close to the imaginary sign, the imaginary letter, that's I. So if we change it now, you see that it will become 3 plus I. So we want to use it to multiply both up and down. So multiply up and down by 3 plus I. And mathematically, nothing has changed. Yeah, because what we did at the top, we're also doing it downwards. So expanding the denominator, this is it. If you want to expand the denominator, just like normal expansion, 3 times 3 is 9. So we have the next thing is 3 times I is 3I. Just like saying 3 times x is 3x. And next, we have 3 times, we have minus I times 3. That's minus 3I. Then we have minus I times I. That's I times I is I squared. Then minus times plus is what? Minus. That's the best way to multiply when you're multiplying. I don't tell people when you're multiplying complex number, try to multiply the I separate, multiply the sign separate, and multiply the numbers separate. And if you watch what I just did now, I said I times I is I squared. Minus times plus is minus. That's to avoid confusing yourself. So you see that 3I minus 3I will give you 0. So that will go. Then 9 will remain. And then you still have a minus there. But your I square is minus 1. So when it goes with this minus, it gives you plus 1. And that's 10 in all. If you repeat the same thing I've just done from the beginning to this, as you apply it to this one, you will be having this particular thing now. You have this particular thing. And what does that tell you? We cannot cancel anything here. 2I plus 3I is 5I, of course. Then I square is what? Minus 1. To remove the plus here. So when you do it, you have 6 minus 1 is 5, then plus 5i. So you may now combine it together. So replace the numerator by what you get at the numerator, 5 plus 5i. Replace the denominator by what you get from the denominator, that's 10. So you see it now. Okay, let me go. I think you cannot see my screen from there. So if you replace it, see what I'm talking about here. So if you replace numerator by this, and that's this thing, now replace it. Then if you replace the denominator by 10, you will have this. Mathematically, if you say this over this, then plus this over this, they are both correct. So 5 over 10 is something as 1 over 2. 5i over 10 is something as what? 1 over 2i. So it's just like separating them. It's partial fraction, but this one is the simplest form of partial fraction. That doesn't have to do with going through a long process. So the real part is the one that doesn't have I. That's 1 over 2. And then the imaginary part is 1 over 2 as well, the one with the I. So that's how to solve this question.